Hello, we're going to be talking about building functions from functions, which is coming from section 4 of chapter 1 of your textbook. And we're going to start with function composition. So if f and g are two functions such that the domain of f intersects the range of g, then we can define their composition. And we'll understand a bit more what I mean by the domain of f has to at least overlap with the range of g in a moment. So f composed with g is denoted by f composed with g, and that's how you read that little open circle, composed with g. It's equal to f of all of the function g of x. So we're literally, wherever we see x in our function of f, instead of just putting x, we put the entire expression of g of x. So first, let's consider f of x is 2x minus 5, and g of x is the square root of x plus 1. Go ahead and before we compose them, graph f and g on the same set of axes, and tell me what's the domain and range of each one of these functions. So this is a line. I trust that you can plot the y-intercept of -5, rise 2, run 1, draw me a straight line. And this is a transformation of our square root parent function. Because it's x plus 1 on the inside here, that's indicating it's going to be shifted horizontally. Your x values are going to change. So I'll leave it to you to think about which direction your square root function is shifting. Go ahead and pause the video right now. Pause the video and try to do part A on your own first. All right, so did we graph our line correctly and state that the domain of f is all real numbers and the range of f is all real numbers? So you know to not have to write out the word domain of f, especially now that we're going to be looking at domains of multiple functions. I'm going to use capital D sub f to mean the domain of f and capital R sub f to mean the range of f. Likewise, D sub g, domain of g, R sub g, domain or range of g. So how did we find the domain of our shifted function? Again, we need the inside to be greater than or equal to 0. So that means x must be greater than or equal to -1. So we see this graph is just a horizontal shift 1 to the left of my parent function here. And by shifting it left, my range is not going to change at all. My range is still going to be 0 to infinity. Again, the square root of anything is always greater than or equal to 0. It's always positive or 0. So no change in the range there. Now, let's look at the composition. So again, in order to take the composition f composed with g, we needed that the domain of f needs to overlap the range of g. And in this case here, the domain of f is all real numbers. Does that overlap with the range of g? Yeah, 0 to infinity is part of all real numbers. So there's an overlap, there's an intersection there. So we can write the definition. So the definition of f composed with g, f composed with g of x is, well, it's f of, and wherever you see x in your function f, instead of putting an x, you're going to put a parentheses and drop the entire expression g of x in there. Go ahead and see right now if you can do that. So pause the video, find me the composition, and then find the domain and range of this composition function. All right, so f was 2x minus 5, so I'm going to write this is equal to 2, not x, but I'm going to leave parentheses, so 2 times the inside thing, minus 5. And what was g of x? G of x, again, was the square root of x plus 1. So what is a formula for f composed with g? What is the equation? Well, it's just 2 times the square root of x plus 1 minus 5. And so what is now the domain and range of this function, this composition function? Well, the domain is still going to be the same, right? The domain of g carries over exactly the same, right? So the domain of f composed with g, since g is on the inside of my function, the domain is going to stay the same as the domain of g. I'm going to have this restriction of -1 to infinity. But whereas the range of f used to be everything, what you'll see is when I compose f with g, the fact that g's got a restricted domain and a restricted range, that range is going to affect the range of this composition. So what is the range of this composition? what we can see right here with this -5, that's a shift down, right? Technically, this is our square root function that has been shifted to the left 1 by having this +1. It has then taken this shape and stretched it vertically up by this coefficient of 2, and then it's taken that stretched version and shifted it down 5 units. So our range of f composed with g is going to be from -5 up to infinity. And again, if you're not quite sure graphically how that works yet, think about it algebraically. The square root of something is at smallest 0. It can't possibly be anything less than 0 because it's positive. 0 times 2 is 0. 0 minus 5 is -5. That's the smallest value. And then as far as what's the largest y value you could get, well, plug in a super duper big number, multiply by 2, subtracting 5 is still gonna be a super duper big number. So to infinity. All right, using that, now try to determine a formula for g composed with f. And now find its domain and its range. Pause your video. Try this on your own first. Pause. All right, so did you get that the composition was the square root of 2x minus 4? If you did, pat yourself on the back. Good job. What's the domain? Again, the square root function has a restricted domain. We need the entire thing inside our square root to be greater than or equal to 0, which means this is going to have a different domain than our other composition. So not only does the order in which you compose absolutely matter, this function's very different than this one, but you're going to have different domain and range restrictions based on how you compose. Possibly, usually, sometimes. Right? In this case, definitely. Your domain is x greater than or equal to -2. And then what's the range? Well, again, this is the square root of something, and the square root of something is always greater than or equal to 0. So your range, the possible y values of this function, are from 0 to infinity. All right, lastly, what does it mean to say f composed with g of -1? What do you think that means? Pause your video and see if you can compute f composed with g of -1. Did you get -5? If so, again, pat yourself on the back. Good job. To quickly run you through it, there's technically 2 different ways you could approach this. You could, without looking at the work we did before, step this through kind of based on the definition of composition, which says f composed with g of -1 is f of g of -1. So you would compute g of -1 first. And since g of x is the square root of x plus 1, you would plug -1 in for that x, and you'd have the square root of -1 plus 1. Well, the -1 plus 1 is 0, and the square root of 0 is just 0. And so then you would plug that number 0 into your function f. So since f of x was 2x minus 5, you would get 2 times 0 minus 5 is -5. Or again, since in part B, I asked you to find a formula or find the actual expression of my composition function, you could just use that and from the very get-go, plug -1 into that whole function, which not coincidentally and not surprisingly works out to be the exact same amount of work we did up here. It's just a little quicker to write. So that's composition. We'll come back to composition in a moment, but first there are a few other ways we can form a new function from 2 other functions that we are starting with. So if f and g are functions with common domains, right, the same domain, then based on some common arithmetic operations, we can add them, multiply them, subtract them, and even divide them. So the rule for division of 2 functions, we need to make sure g of x is not equal to 0, of course, so we're not dividing by 0. So this often makes this division have an even more restricted domain than what it would have had. So I should also specify with common domains, by common I don't necessarily mean exactly the same. Again, common I mean there's overlap. So looking at our same example functions again, f is 2x minus 5 and g is the square root of x plus 1. Find the following of each plus the domain of each. So give this a try. I, double I, triple I, and little 4i, I guess. Pause and compute. All right, so when we add our two functions, we literally take the first one and add it to the second one. You do not need to show this first line of work. You can and hopefully should be able to just when you're adding straight up at them. What's the domain? Well, the only domain restriction we have is coming from our square root function. And so the domain of their sum is the same as the domain of just g, the square root function. When you subtract, again, the same thing. It's going to be 2x minus 5 minus the square root of x plus 1. And the domain is still -1 to infinity, including -1. Their product, so it's f of x times g of x. I highly recommend you put big parentheses around each of these functions. For instance, 2x minus 5, instead of just writing 2x minus 5 dot the square root of x plus 1, put parentheses around it. And what this technically means is you can distribute and multiply this square root to each piece, and then you'd get something that looks like this. But really, this looks worse than it did when it was in factored form. So the product of f and g is just the product of f and g, 2x minus 5 in parentheses times the square root of x plus 1. And again, the only place we're having issues in our domain is coming directly from g, so the domain is the same. Now, when we have the quotient, right, f of x divided by g of x, put them on, and there's nothing we can simplify, so the function is exactly the way it is. And usually it's written f over g of x. That's how I typically write this, instead of f divided by g. So what's different here is, notice now our denominator cannot equal 0. So instead of saying that x plus 1 must be greater than or equal to 0, it can't equal 0. So we now have an additional domain restriction. So my domain is now everything strictly greater than -1, no longer including -1, since that would mean I'd be dividing by 0, and that's a no-go. All right, let's talk about composition one more time. So it is as important to be able to undo the process of function composition as it is to do the process of function composition. Unsurprisingly, this is called function decomposition. And this is a really important skill to have in calculus, especially when it comes time to take derivatives of compositions of functions. It's being able to look at something like this and say, to me it looks like there's an inner function and an outer function. This to me looks like some outer function f that has an inner function g inside of it. So when you look at this, do you see an outer function and an inner function? Hope so, yeah. The inner function is, or could be, right? We can say let g of x be the line 3x minus 5, and then the outer function, right, f of x would be just then the square root of x. And then if we compose these, f composed with g, right, f of g of x, we would have the square root of 3x minus 5. And that will do it for the first video, the first half of 1.4. The second half, we're going to focus on implicitly defined functions and what that is. So now please go to our next video.